Hello everybody, and welcome to Operations Research video lecture. So we are looking at linear programming with SPICE, chapter 6, that was entitled Diet and Nutrient Problem. So the diet problem, this we have solved and analyzed a little bit, and now it's time for the nutrient problem. And yes, what's going on here? So the product mix problem 5.1 and the diet problem 6.1, we learned that they were closely related, of course. Solution was as when we coded it and told Octave how to solve it, or how we modeled them as LPs, they were very close to each other. So basically maximization turned into a minimizations, and upper bounds turned into the lower bounds, and not based, in principle. That was exactly what happened. And then, I mean, intuition tells us that this should be more or less the same problem, but what is intuition? It is, according to Albert Einstein, intuition is a collection of prejudices we collect before we turn 18. Meaning, sometimes the intuition is right, sometimes it's wrong, and in this case it was wrong. So it was intuitively clear, and it was completely wrong. And what happened? Well, one thing is that the more deep bakery, it had all the nutrients that seed stubborn needs, but it cannot provide the nutrients because there was the more deep bakery turned those nutrients into cakes, and then seed stubborn or naive Stilgar wanted to buy those cakes in order to somehow extract the nutrients or have enough nutrients for them. And now what happened in the middle, it was producing these cakes. The way that was optimal for the bakery to bake those cakes, and what would be optimal for seed stubborn to buy these cakes in order to have the same amount of nutrients. Actually, it's the optimally, there were different optimums, so it's something was in balance here, and the imbalance was the baking the cakes. So let's suppose that seed stubborn is happy to just have the nutrients directly, and then, I don't know, maybe they can consume those powders directly and not make any cakes out of them, or maybe they bake their own cakes. So let's somehow forget baking the cakes, and let's think that, okay, the seed stubborn is only interested in its nutrients, so they are going to buy these nutrients directly from more deep bakery. And since the nutrient requirements are the same as the daily nutrients available in the bakery, it means that they are basically buying that day's business from more deep bakery. So naive Stilgars go to the bakery and says, sell us all your nutrients, so don't bake any cakes today, I will buy the nutrients. And then, because he's buying all the nutrients and the nutrient amounts is precisely the one he needs, he has what he needs, and maybe the bakery is happy with the offer that naive Stilgar is going to make them, maybe not. So now it's the question, what should naive Stilgar offer to more deep bakery be? So what kind of offer should naive Stilgar go to the more deep bakery so that he buys the nutrients, and the bakery is happy, and the seeds is happy, they have enough nutrients. So this is problem 6.8, seed stubborn nutrient diet. So I just explained that knife Stilgar must feed his seeds. Okay, the seeds needs 5 kind of nutrients: fat, sugar, protein, water, and spice melange, and these are the requirements. And now Naib Stilgar is going to Muad'Dib bakery to buy these nutrients. Okay, so how do we make an LP out of it? And yes, let's follow the algorithm 5.2. Step 1. What should be the decision variables? So what can Naib Stilgar decide? So now it's not completely clear, especially in this what is given here in the problem 6.8. And also know that there is some data missing here. What is the data? The data is the same as we had before. That is how basically the business model or the technology in the Muad'Dib bakery. Okay, decision variables. So he has to decide, well, what is asked. What is asked is, of course, that what is the offer Stilgar is going to give, and this offer is of course, it's a single number. It's a number of Solaris. But how to arrive at this offer? So what is that we want to buy? And yes, we want to buy these nutrients directly. So we are not buying cakes now. We are buying nutrients. We are buying the raw material. We are buying fat powder, sugar powder, protein powder, and this very strange water powder and spice melange powder. And we want to, obviously minimize something. So now this, you have to give this a little bit of thought, but in the end you realize, or kind of, if you don't realize this is something that you should, I think you, after some thought, come to the guess that maybe, since we are buying nutrients directly and we want to minimize the cost, then maybe our decision variables are how much do we pay per unit for each powder. So our decision variables, and now I call them y. Why? Well, since the x's were for the bakery problem, and I want to make comparisons, so I need a different variable, and since you know alphabets how they call, after x comes y, so it's y. And how many there are? There are 5 of them, because there are 5 powders. So we have prices y, y1, y2, y3, y4, y5, and column vector, as always, will be the offered prices per unit for nutrient powders. Okay, that's what we have to decide. So step 1 was now a bit more difficult than in the previous section, so sometimes the decision variables, you have to be clever in defining them. And this is the way to do here. Okay. So here, let me scroll down a little bit, is just to emphasize. So Y1 is price in Solaris of 1 gram of fat powder, and so on. Okay, step 1 was done. Step 2, objective function. And now this is maybe the place where we understand why the decision variables were what they were. So objective is to buy these nutrients from Muad'Dib bakery, and as with the minimal cost, yes. And so there's a minimization problem, and what is then the price to be minimized. So now again I make the unit change, so I measure everything in this is in grams, this is in grams, this is in grams, milliliters, and milligrams. And Y1, Y2, Y3, Y4, Y5, they were the cost per unit. So the units were decided to be these. So then the total cost W will be, of course, we need this much nutrient 1. This is the price per unit, so this is the total price, and so on. Okay. Then what we have is step 3. And we need to find constraints. And this is okay. What are the constraints here? So where do they come from? And the idea is obviously that we are making an offer, which is of course the W simply, but we have to think, would More Deep Bakery accept this offer? And why would More Deep Bakery accept this offer? So Stilgar goes there and tells that this is the offer. Maybe he also tells these whys. Would be a good idea. Not necessary though. And now, okay, maybe let's assume that the offer will be actually this Y. So Stilgar goes to More Deep Bakery and tells that I will buy all, that's important, I buy all your nutrients, and this is how I will pay for them, its nutrients. Okay. What does the More Deep Bakery contemplate now, think now? Now they have two choices, yes? One is to, okay, I accept the offer. Here are the nutrients, give me the Solaris, see you tomorrow. The other one is that, okay, I refuse. No. Instead, I use the nutrients myself, and I bake some cakes out of them, and then I sell the cakes to anyone. You can buy the cakes, or someone else will buy the cakes. I don't take your offer. All right. So this is the negotiation situation at the moment. And to understand what's going on now, we need the data from the More Deep Bakery. So this table, Fremen cake type table here, you should be very familiar with this table. By now we have seen it many times. So now we are actually, so we were reading this table row-wise in the More Deep Bakery problem 4.1 or 5.1, same problem. What we do now is that we read it or think about this column-wise. Now we suppose that this vector y, so y1, y2, y3, y up to 5, these prices per unit for nutrients, the offer is given, and the More Deep Bakery think about whether to accept this offer or not. And okay, if you don't accept this offer, or what is the alternative? So More Deep Bakery can use these nutrients itself. So for example, it can turn 70 grams of fat, 500 grams of sugar, 280 grams of protein, 600 milliliters of water, and 8 milligrams of spice into a cake. These are Atreides cakes that sells for 120 Solaris. So we are looking at the first column here. Okay. Or we can sell these ingredients, these nutrients, with the prices y1, y2, y3, y4, and y5 to Naib Stilgar. Yes? And we get this much of money. So this would mean that we sell these. And this would mean that we don't sell them, we use them ourselves. to bake cakes. In this case, a trader's cake. Well, if this is bigger than this, then it means that we get more money out of selling these nutrients, this amount of nutrients with these prices, than use the nutrients ourselves and bake our trader's cakes. So this means that selling them would be more profitable to us than making a trader's cakes out of them. Okay, but that's good. If this is the case, then we are still saying, okay, maybe we could, looks good. But then, of course, we don't only have a trader's cakes we can make. We can make Corino cakes also. So then we think, how about Corino cakes? Are these prices, these Y prices, selling prices for the nutrients, good enough so that it's even better to sell them than make Corino cakes? So then we do the same analysis with the second column. And yes, of course, the same with Harkonnen cakes. I mean, same thing here. So these are the following conditions. So if the prices here are better than 170, it means, okay, it's better to sell them than turn them into Corino cakes. And then finally, this one says, okay, it's better to sell them than turn them into Harkonnen cakes. So if all these 6.9, 6.10, 6.11 are true, then it means that by selling our nutrients with the prices Y that Knife Stilgar is offering, Stilgar is giving us a better deal than we can do in our business in baking them. And then, well, I suppose we should be happy. Why not? We get at least as much as we could get by baking them into cakes. So it would be kind of rather silly of us, if you only think about Solaris, not to sell. Okay, but there you have it. Here it is. So that's the problem. Now let's get back to Sid Stabr and its leader Knife Stilgar. This problem is to minimize. This is a total cost of buying. Here is the nutrients. Know that there is this K for kilos. Reason for this was marginal. I mean literally marginal. So if I put here 100,000 so on, I mean this the margins of the paper are not wide enough. So I used a little shorthand there. So the minimization is to minimize this objective here, subject to these constraints. So all these three constraints, they are related to, so the first one was related to Atreides cakes, second one Corino cakes, and third one to Harkonnen cakes. And yes, we always have these sign constraints, almost always. So if I make an offer like this, then objective is clear. This is my objective. I want to minimize. And if these are true, then all these lines tell that all these choices that the bakery has to bake the cakes, I'm giving for every cake or every product they have, I'm giving a better deal. It is better for sell the whole stuff to me than to buy the cakes, because with the cakes you cannot get enough. Your selling price will be lower for the cakes than the selling price for us being now Knife Stilgar. Okay. So that's the LP. And that's the solution for it. And for the rest, solving it and a little bit of analyzing it will be the topic of next video lecture. See you there. Bye.